Hi, this is MIS 547. I think it's called Foundations of Cloud Computing. I just call it cloud computing. If you're not in the right place, that's okay. You're welcome to stay. But I hope you are in the right place so we can have a really fun semester together. Just a quick check, show of hands. How many here are second years? Okay, and how many of you are in MIS? Okay, so just, all right, cool, great, perfect. That's awesome. Everyone who's not in MIS, or if you're not a second year, you're still welcome. I'm very happy that you're here. Okay, so just a little bit about me. I'm Zara. Last semester, folks called me Professor Zara, which made my 5-year-old niece giggle to no end. You're welcome to call me whatever you want. Z, Zara, Professor Z. Started watching some X-Men. There's like a new season of X-Men out, and I was like, oh, I could be Professor Z. Why didn't I think of that? So yeah, that's me, but literally whatever suits your cultural sensibilities or sense of decorum, it's up to you. So a little bit about me. I do security data science at DigitalOcean. If you're not familiar with DigitalOcean, you will be. They're a major cloud service provider, like AWS, like Azure, and like GCP, shouldn't leave them out. Yeah, and so I work on their security team, and I design detections using data science to secure the internet from DO, secure DO from the internet, and secure DO from DO. That's kind of the security mission statement there. I'm adjunct here at U of A. I graduated from the MIS department, 3 years ago? Yeah, that went fast. And I was in the AZ Secure program, yeah, had a really great time there, and that really launched my career. But the MIS program in general is fantastic. I'm really excited that all of you are going to graduate in less than a year. So that's exciting. I also, because I'm a little bit too academic for industry and I'm a little bit too restless for academia, I started my own research lab. It's called Z Collective. And I have a bunch of amazing people who work with me. We do research like AI for security research. We do some cloud native development research. It also helps fund this course and all the activities that we do. Yeah, and it's here local in Tucson, but we have collaborators so far all over the country and even across the pond. Yeah, that's my org for the moment. Yeah, so let's talk about what we're gonna do in this class and what the goals are. If you were super nervous about joining this class, I don't want you to be. We're not all going to be certified Kubernetes administrators by the end of this class. That's not the goal. The goal is really to just get a really good foundation in cloud computing, and then we'll go into depth in particular areas. But you're really not expected to leave this class being a cloud DevOps engineer. But if that's what you want to do, this will get you a good amount of the way there. So we really want to be able to compare and contrast the major communities, the major corporations, the organizations that are in the cloud world, and also the cloud native world, and just kind of really get some familiarity with the differences and architectural approaches with cloud hosted or cloud enabled technologies, and also cloud native technologies. And we're going to talk a lot about cloud native and what cloud native means and why it's such a big deal right now. And then we're going to move on to be able to actually evaluate those approaches, evaluate cloud hosted approaches and evaluate cloud native approaches, figure out what works the best for us. So raise your hand if you are intending to go into a product management or project management role. Okay, cool. And raise your hand if you're going to data. All right, cool. And something else. Yeah, kind of development or
like enterprise information systems.
Oh, cool. Yeah, awesome. And there was another.
Kind of research with Bell and idea.
Oh, cool. Yeah. So more on the research side or the applied side? Anyone else? Any other objectives? Okay, cool. So for a lot of product and project folks, understanding why we're going into such technical detail about some of these topics is kind of a struggle. And I just want to put it out there that the best product managers that I've worked with so far, which hasn't just been the 3 years since I graduated, I worked a considerable amount before I came to school. The best product managers really have a great technical foundation to advise their approaches to product management. Same thing goes with project management, especially if you're in charge of budgets. Knowing the fundamental technologies behind what we're deploying is going to help you save so much money. If you are kind of at the whim of, whatever new something as a service that AWS rolls out or that DigitalOcean even rolls out, and you don't understand, like, how would I implement this on my own? It's really hard to make an evaluation of, is it worth it to take on the additional costs to implement that software as a service, approach rather than roll our own? It's really important to be able to understand, like, scoping, like, how long is this project actually going to take to roll out? And there's always those lies that we tell our management, right? Of like, oh, it'll be November. But then, like, the engineers, the product and project managers, we all actually know what the real timelines are. You're going to have a lot better sense of what that is if you understand the technical foundations. So that being said, this class is pretty technical. So the assignments are all, was that me? Sorry, I'm pretty sure I put myself on Do Not Disturb, but if that was me, I apologize. That happens to me every once in a while. I get distracted. So I was talking about project and product managers. Okay, the class is very technical. All of our assignments are going to be, really driven by code. There's not a lot of like written assignments. There's not a lot of, fill in the blank kind of answers on the test. It really is driven by the technical underpinnings. You'll have some opportunities to like express yourself, through written reports or through like blogs or through, if you want to do a vlog, it's a little bit younger than me, the vlogging generation, but but if that's what you're interested in doing, you'll be welcome to express yourself that way, but we are really going to focus on the technical capabilities here. And I don't want you to feel like you're alone in that. We have a lot of support, we have a lot of resources available to you, and I'd really like for this class to actually become each other's biggest advocates and biggest allies as you're working through these sometimes pretty difficult technical challenges. So that said, this is not like a application development with Python class, right? This is the foundations of cloud computing class. So you're not going to be writing like massive, web apps in Flask and Django or whatever. If there is code for that, I'll provide the source code, like foundations of it. You'll clone that, you'll deploy, change what you need to change, and that'll be your assignment. Next we want to describe security and privacy concerns in cloud environments. And I say, describe them and just be familiar with them and aware of them. You're going to do some threat modeling of some cloud architectures in your group project, which should be fun. Again, I'm not expecting you to be able to pen test Kubernetes or hack Kubernetes or win a CTF at KubeCon. Although if you do that, that's awesome. Tell them I sent you. But yeah, we're really just looking at like a high level, like what are the key things we think about with cloud security? And that's gonna be baked in throughout the whole course. And then I'd like for you to be able to make like just sound recommendations regarding cloud technologies and articulate the rationale behind them, right? That's a really key point. A lot of people will talk a big game. Oh, well, this is obviously the best way to go about it because, Hacker News said so. I'd love for you to be able to be like, actually, if everyone here could go on Hacker News and like Reddit will actually post, that would be amazing. That would be a huge win. So, so let's talk about everything we're going to cover. Unit 1 is going to be these cloud fundamentals. I say fundamentals or foundations. That being said, it's not like that straightforward, right? I don't want you to think it's like baby cloud. Nothing in cloud is really like introductory, I wouldn't say. So we're going to go over like the key components of cloud resources. It's going to be compute, database, storage, and network, and then we'll have our first exam. Unit 2 is going to be our cloud native technologies. So that's where we're going to introduce serverless. We're going to introduce microservices because those all kind of tie together. Infrastructure as code. This is where the stuff gets really fun, and you kind of get to get a feeling of how a lot of the internet works these days. And we'll do a week on Kubernetes, which I know does not sound like a lot because it's not. You could do a year of Kubernetes and still feel like you don't understand the basics. Speaking from personal experience, and then we'll get more into kind of DevOps principles in general. And then our special topic for this year is going to be MLOps. Yay! And that's going to cover both kind of, I would say, it's funny to call it like traditional ML. When we say AI ML, 2 years ago when we said AI, that meant deep learning, right? And now it means explicitly, like specifically large language models, generative large language models. That's what we mean when we say AI. I take a little bit of issue with that terminology, but we want to include the rest of it by saying ML. So we'll say ML ops, and that'll be deep learning, traditional machine learning, LLMs. We'll get into some RAG. But yeah, it's we have 2 weeks for that. So it'll be ML ops and also kind of taking a step back and looking at larger like cloud architectures and how do we integrate all these microservices and how do we design these architectures. So then you can go read a really insane, hairy, AWS network architecture diagram and be like, oh, okay, that makes sense. So yeah, so as far as office hours, I will have my office hours Wednesdays at 3 p.m. They are going to be virtual unless there's like a strong need for them to be in person. That helps to facilitate like my travel schedule a little bit as well. And they'll be by appointment. So if you would like to meet with me for office hours, you're welcome to. And if 3 p.m. Wednesday doesn't work for you, you have conflicting courses or whatever, you're welcome to send a request and we can work around that schedule. Then our TA for the semester is Vetri. He's unable to join us until next week, but he will have his office hours Fridays at 11. And that's also by appointment. So just send him a message, send me a message. But really, we're hoping that the majority of our interactions will be in Slack. We'll be answering a lot of your questions in Slack. Okay, the rest of the course is structured like this. We're going to have weekly assignments, and those are going to open Sundays at midnight. And that's going to be due the following Sunday at 11:59. So you'll have a full week to complete it. Some of them you might run fly through them. Some of them you might get a little stuck. So I encourage you to start them early if you can. And those are all going to be through GitHub Classrooms. So I'm not sure if anyone's used GitHub Classrooms yet with other professors. So it's a nice way of kind of assigning you basically a fork of the assignment. So it'll be through your GitHub account, and you'll get a copy of it. You can you'll clone it. You will fill it out. You'll do any tests you need to do, and then you'll just push it back to your branch, and then it will submit it as the assignment is completed. So I was realizing literally just yesterday that one problem is that D2L wants some kind of submission as part of the D2L like LMS. So in addition, if you can just go ahead and in the assignment submission box, just like drop a link to your repo, that would be great. Just that way we have a record that people have submitted in D2L, even though we're going to be grading all of it in GitHub Classrooms. I'm so sorry for the duplicated efforts. I will figure out how to automate that someday. But right now D2L and GitHub Classrooms are not integrated. So that's our weekly assignments. Then weekly quizzes are going to open after class on Thursdays, so about 5 p.m. So you'll have until Sunday at midnight to finish your quiz. They are short, 5 questions. You're going to see some of the same quiz questions on the exams, and they're kind of designed to make you dive a little bit deeper into the readings. So there will be some content from the lectures, definitely on the quizzes, but they are also around the readings. And I've structured the readings in a way that it's going to help introduce you to a lot of other materials that are going to help you keep learning after this class. So that's going to be some of the authors that are really prominent in the scene right now. Lots of O'Reilly textbooks. Everyone has access to O'Reilly through your university account. If you have trouble accessing O'Reilly, let me know. I'm happy to help troubleshoot that. It'll be YouTube videos from like conference talks or recent conference talks, old conference talks. There's some really amazing conference talks that came out in like 2012, 2013 when like cloud native was just getting started and Kubernetes was just being introduced. It was a very exciting time. So there'll be a huge list of resources, blogs that I follow, all these things. And also some of the reading content comes directly from, my colleagues and like our tech water cooler. And it comes from like all these different Slacks that I'm in. I'm like, oh, cool. Like who's talking about this? And then I spread them to all of you. So it really, I try to have it be kind of a mix of cutting edge, latest and greatest thought leadership right now, also O'Reilly textbooks, also conference talks. So I hope it's enjoyable. If reading is not your style, I totally get that. I've tried to keep the O'Reilly textbook chapters or those assigned readings to like 1 chapter or 2 chapters of a book per week. So you're not kind of bogged down in a lot of technical language. Yeah, and then lectures are going to be recorded. And then some lectures will be online only, and that's just to accommodate some work travel. There's a couple of things that are coming up. I'll have announcements. I've put them in the syllabus like when I'm out, but there'll be a few weeks throughout the semester that I have to travel. So I apologize for that, but the lectures will be pre-recorded. If y'all want to meet in class, you can, but there's no requirement to. If you just love hanging out with each other, which I hope you do, you're welcome to come. Okay, so now let's talk about Slack. Communication guidelines. We're gonna use Slack for as much communication as we can. In the D2L left-hand navigation, there's like the getting started section. And then there's more details about like ways that you can actually earn extra credit in Slack. So there's a few opportunities for extra credit. We'll get into a lot of them, but for Slack, you can earn over the course of the semester 20 points of extra credit. And we're going to kind of look at that every week. So how engaged are you in Slack? If you're asking questions, if you're answering questions, if you start a thoughtful conversation that has like 3 or more replies, those kinds of things. So really just establishing that good citizenship in Slack is really important because guaranteed as soon as you leave here, you know, the rest of your professional communication, maybe for the next like 5 years, is all going to be in Slack. So kind of establishing that early and having some good practices and really thinking through like, oh wait, how did I type that out? I want to like pause, think about how I said that, try again. Yeah, just having some well thought out, well formatted answers to questions is it's a skill and we kind of have to develop it. Please post your questions in public channels in Slack so that I can see them. If you post it in a private channel that I'm not in, I won't be able to. Yes.
It's not letting me.
I heard that this was an issue for someone else. I think that's a me problem. I might have linked just to the workspace instead of adding the link to the invite to join the channel. I'll do that right after class. I'll either send an announcement or I'll just send it all to your emails individually. Yeah.
Okay.
Thanks. Yeah. Of course, if you have a personal question, if it's about your grades, if it's about your life blowing up and like, I mean, like, you know, chances are someone's life is blowing up at any given point in time, right? There's enough people in here that like pick a week, right? Something's going sideways for someone. You're welcome to DM me. You can email me. That's fine. But as it's like a question about an assignment, we have specific channels for each assignment, public channels for each assignment. We have like a general channel for just general discussion. If you see some hot goss in hacker news, or if you see something that you want to share with the rest of the class, like obviously put that in a general channel. Okay, so important dates. There's gonna be 3 exams. We're not doing like a final comprehensive exam because we cover so dang much in this class. I feel like it wouldn't be fair. So we're gonna do exam 1 on unit 1, exam 2 on unit 2, and exam 3 on unit 3. And then we'll have our group presentations December 5th and December 10th. So I did try to build around like Grace Hopper, but now I know that I didn't need to think about that actually, which is okay. But if you are attending Grace Hopper for any reason, then I've worked around that conference schedule. Okay, all the extra credit opportunities. Yeah, we've talked about Slack participation. There are 3 other ways to earn extra credit. I think it all adds up to about 60 points of extra credit, which is like a full letter grade. So if you're really struggling in the assignments, or if you really bomb an exam, just by kind of showing up doing community stuff, you can salvage your grade. The first one is debugging. If you debug an assignment, and by debugging, I mean like a significant contribution to debug it. Like if I misspelled something, if there's a typo in like a instruction, I'm happy that you point that out. Thank you so much. But maybe that's not extra credit worthy. But if it's like, Zara, like this doesn't work on Windows at all. What did you do? I got a BSOD, you know, here's how I fixed it. If you submit like an issue, or if you resolve an issue in the assignment, you can earn extra credit that way. I would love to see that. I guarantee I got something wrong at some point. So just keep an eye out. And then also if you communicate that like in Slack, that'd be awesome too. So I'd encourage you to submit an issue in GitHub, because that'll be sort of like the first person to like officially submit the bug, as opposed to just being in Slack, because then it's harder to tell like who is first or whatever. But yeah, and then also gets used to submitting bug fixes in GitHub, which is a great practice for open source communities. Then there's course evaluations and surveys. There's going to be 2 or 3. I forget, but there'll be a mid-semester one where we just kind of check in with each other and we're like, what's going well? What's not going well? How would you like to see this class evolve? Or, what else can we do to make this more engaging or enjoyable? And then there's 2 other surveys that we'll do at the end of the semester. And then community involvement. So this could be a lot of things. This could be, I would love for you to check in with me about it because I might know some people who can like help with whatever you're interested in doing. Or also if you, I can let you know if I think that project might go sideways. But say, for example, you submit a CFP or a call for participation for a conference. That can earn you extra credit points. So if you see a conference and you're like, hey, that looks cool, I think I have something to say there, which I guarantee all of you do, and you submit a CFP, even just submitting that CFP, you can get extra credit in this class. It should be related to the class, I should say. If you participate in some like open source hackathons, I think there's one on campus in the fall. So if you participate in that and it goes well, you maybe put like a team together, you can get extra credit that way, depending on the effort or how you organize it, how you get involved. It'll be different levels of points. There's an event called Hacktober. That's a big open source like hackathon that happens around the world, and that's in October. If you participate in that and kind of really take it seriously, you can get a lot of extra credit that way. And if you decide to like really go deep on like the cloud and university alliance engagement kind of thing, there's like AWS has campus ambassadors. If that's something that you're interested in looking into, that will definitely get you extra credit in this class. Those are just a couple of ideas. There's so much you can do out there, and I would just love to see people contribute to open source. If you're like, hey, here's an open source project that I've been looking at for a while, I'd like to start contributing to open source. That's a scary thing to do, so you will get credit for it. Yeah. So any questions so far? There's a lot to get through. I promise we'll get to cloud stuff soon. So my policy on using generative AI in this class. Please don't use generative language models for any written assignments, for any blog posts, for any CFPs. I know that it's getting much harder to detect text that's been generated by LLMs. I have some models in my toolkit that I've built, that I've customized to do that. They're getting less effective, and I acknowledge that, and I don't really have time to retrain them. So please don't do it. Being able to generate your own thoughts, your own writing, your own style, and not have this bland vanilla. I'm so sorry for everyone who's like a Gen A. I'm sorry. It's hard for me to like hold back about this, but like it's really important to have original thought with the internet. Even if your language models are like these larger language models are going to incorporate that, having diversity is so important. Please let's not let the internet die. So getting into the practice of generating your own text, generating your own thoughts, your own writing, especially if you're publishing it somewhere on Medium, you're welcome to like start writing it. Use Grammarly to check your grammar. That's fine. If you ask ChatGPT to generate a blog post for you about a thing, that's going to break my heart. So please don't do that. You can use Copilot in this class with a big caveat. I only say you can use Copilot because I know you already have licenses, and I'm not going to say that you can't use it. That's correct, right? Everyone already has licenses for Copilot. Is that everyone's understanding?
I don't know.
You're not sure? Okay.
You have to sign up for it. Yeah.
Okay, got to sign up for it. And there's an academic, like free usage tier. Okay, cool. All right, great. So because it's available for free, if it was paid, if you didn't have academic licensing, I would have said, no, there's no way you can use Copilot in this class. It provides an unfair advantage over students who can't afford it. It would have been like $40, I think, over the course of the semester. But since everyone has it available to them for free, I'm not going to say like, no, you can't use a thing that's available to you for free. That being said, you're responsible for all the code that you generate. Any code that you commit anywhere, right? Like if it's an open source repo, if it's at work, if it's in this class, you're responsible for it. If you don't understand how that code works, that's on you. If you're using generative AI for generating code and you haven't gone through and debugged it, that's going to reflect really poorly on you when it comes time to turn in your assignment, when it comes time to submit a PR at work. It's going to be quite embarrassing. So, save yourself the hassle, and also, I've read a lot of studies about developer productivity using large language models. I'm happy to circulate those around. The metrics are all over the place. It's like, oh, language models are coding assistants, generate more insecure code or less insecure code, or they make developers more productive, or it's about the same. Like no one really knows how effective these are, I wouldn't say just yet. Like we really need to have like a focused study that has a larger range. So it is what you make it. If it makes you happy when you're coding to use Copilot, then that's great, but you are still responsible for it. I find that it turns me into an editor, and I don't like being an editor. Like, I want to create my own stuff. So I'm using autocomplete. I'm like, no, stop it. Anyway, so that's my soapbox. I'm off of it. And apologize if I slip into like less kind language about generative language models. That's not my intent. I'm not trying to, radicalize anyone. I just have some strong opinions. So, all right. So here's what's due this week. There's a course pre-assessment, and I would just like for you to fill it out. It just is trying to gauge like where you've come from, where you're trying to go, right? And then that's going to help us put your teams together. And it's going to help us, kind of tailor the course a little bit more. Assignment 1 is due Sunday at midnight. You should have, let's see, I think I posted about assignment 1. That's visible in the course, in the course materials. Oh, great. Okay, perfect. And I think I added that thing about just adding the link in the assignment 1 submission in D2L. I know that's annoying. And then quiz 1 is going to be due Sunday at midnight. Also, that doesn't open until Thursday. And then lastly, I have a big surprise for everyone. I'm really excited about it. After last semester, I found that people's student, your student developer credits through like the GitHub student pack or through AWS free tier, Azure free tier, like people were burning through them. They went really fast because of this class, because of other classes. This is not the only class that uses cloud technologies, which is a good thing. But people are really running through their credits, and we have a full semester of resources that we need to persist or spin up or take down. And you make mistakes, right? Someone burned through their credits because they, spun up an image in one AWS region, forgot that that was there. They were in a different region in the portal by default, and then they just lost all their credit, $200 overnight, right? It's like, it is insane. Cloud computing is really expensive. So with that in mind, I advocated really hard, and my director is amazing. And DigitalOcean is fully funding our course this year. Yay! So we have unlimited compute, basically, and we can spin up resources however we want to for your assignments. You can have your resources, you can persist them, you can take them down if you want to, if you're not really using them, that's fine. But then more importantly, for your group projects, you can start experimenting with infrastructure, you can spin things up, you can test things out, and you can have them run for a longer time without being worried about incurring a lot of costs. So that being said, I am gonna monitor maybe once a week, just make sure that nothing's going crazy. Security knows that I'm doing this. So if we get locked out of our accounts, it's not a big deal. I can unlock them. But we they agreed to fund this course, and also they're really interested in your feedback. They really want to know how what the experience is operationalizing a large language model in the cloud, or how you find the whole process. Parallel with this class, DO is working on all these other products and stuff. I can't really talk about it publicly just yet, but it's aligned with some of the stuff that we're doing. So I might be able to have us have early access to those. We can try them out. We can discuss, the differences between roll your own and something like that. So there's a lot of opportunity there. But yeah, it's a really nice thing that they did, and I'm really stoked about it. So yay. We will probably have a press release about it on the U of A side and on the DO side. I'd love to get a picture with everyone if you're okay with that. But yeah, and then we can be yay. Cool. So that's a big announcement. We don't have to worry about money this semester. Yeah. Okay. So let's get into the lecture proper. Well, actually, let me pause for just a second. I just talked so much. And that was, are there any questions about how the course is set up? Any questions about assignments, extra credit? There's a lot more details in the syllabus. Please do read that. I worked very hard on it. It has all the dates. And yeah, I think everything's there. And if you find a discrepancy in the syllabus, especially around dates, oh my gosh, if you find a date discrepancy, you'll get extra credit for that. I tried real hard. Okay, any questions? No? Okay, so with that, let's get started. So this is lecture 1. We're talking about what is the cloud. Does anyone have ideas? Let's just put it out, even if it's a rough sketch. What is the cloud? Just take a stab. Doesn't matter. Yeah, go ahead.
It's a collection of computers that are connected to one another that can communicate to one another.
A collection of computers connected to one another that can communicate to one another. Yeah, that's great. What I like about that is that you talk about sort of a pool of resources, right? And you're talking about connectivity, networking, internetworking. That's great. It's a great start. Yeah. Anyone else?
Kind of to add on to that, I think of like whoever is using the resources, their experience is kind of abstracted from like the bare hardware. Like they're not actually like controlling memory in a specific machine or something, they're just running the program.
Yeah, absolutely. Abstraction is a huge part of the cloud. We're going to talk a lot about virtualization next week. But yeah, that's exactly it. Like you're not really controlling the underlying hardware, the underlying physical infrastructure. That's kind of provisioned for you. It's available for you. And then you're working on top of that. Yeah, it's a great part of that. Any other pieces? Thoughts?
I mean, it's running or storing data on external servers or computers as said before, but it allows you to expand and your resources and reduce resources as necessary. So you have that agility.
Yeah, that's great. That's great. Yeah, expanding resources as you need them or having resources available as you need them. We call that elasticity. So it's a really, really great definition. These are all like key parts of what the cloud is. Yeah, anyone else? Okay, well, the joke answer is the cloud is someone else's computer. So I mean, it really is true, like quite literally. So in the top left, that's my buddy Aaron. That's his server rack, and he has a managed service provider for a lot of like small websites out in Brooklyn, and that's in like a little closet in a transformed warehouse out in Bushwick. Like that's a cloud. Technically, it's a private cloud. We also have massive data centers. Just I don't even know how many like thousands of miles of cable. Right? We have that interconnected part. We have that piece where we're not working with physical infrastructure. That's there. That's someone else's. We're working with layers of protection on top of it. And because we have this much compute power, we're able to do things like auto scale up or scale it in response to the amount of traffic that our website is getting. Here's an example of someone else's computer. This is a data center. I think this is in Virginia. Is that right? I can't remember, but it's a football field, right? This is a football field size data center. And this is just one. This is just one of these. These are all football fields. These are all data centers. So this is Azure's someone else's computer. This is the Azure global infrastructure. This is the Google Cloud Platform global infrastructure. They have these data centers all over the world, right? And it's not just like one center. We'll talk about it a lot more, but there's different regions within one data center, and different locations within each data center. So you can have within one region, like redundancy within that same region. There's a lot going on here. And then this is the AWS global infrastructure. I think this has expanded even since this screenshot. Anyway, yeah, I mean, it keeps growing. DO just added, when I say DO, I mean DigitalOcean. I'm sorry, I'm so used to that abbreviation. But we're adding data centers in Australia. We're all constantly expanding, and we get to use all of this compute. So what this class really is about is kind of understanding, like, we have this global massive infrastructure. We have global workforces. We have people working around the clock, quite literally, to support hundreds of services that we can all use in the cloud. And how do we leverage that? Like, what do we do with that? What are we doing? Like, how can we turn this into something that a small business, for example, can take advantage of? Like, how do we turn this into Netflix? Like there's so much available here for us to learn and to take advantage of. What does this mean for us as project managers or product managers? How can my data people take advantage of that? How are we serving, like how do we turn all of the GPUs in one of these data centers into OpenAI? Like how do we turn all of that networking into Netflix? That's kind of what we're going to explore in this class. So what I want as a result of this class is for you to have the knowledge to leverage these cloud services. And obviously we cannot cover all of it. Like even just AWS, there's 230 services last I checked. That's probably more by now. We're not going to get into each individual one, but what I'd really like for you to do is just really understand the basic building blocks and how it all works together. And that's why we're covering these particular topics. And that's also why the reading is selected as it is, so that you can kind of bookmark your favorite authors, bookmark your favorite blogs, and then go back to them, keep revisiting them, because this is the rest of your life. I'm so sorry. You're gonna have to keep reading forever and always. Yeah, so make sure that you're reading someone that you like at least, right? Okay, so we touched on a few of these already when we were talking about what is the cloud, but NIST, or the National Institute of Software and Standards, of Standards and Technology, has kind of consolidated this into a clear definition. And the characteristics of cloud computing, according to NIST, is on-demand usage, ubiquitous access, multi-tenancy, elasticity, measured usage, and resiliency. So that's kind of, how NIST, put on their thinking caps back like 10 years ago and started defining what cloud computing is. So let's talk through all of those. So on-demand usage, that just means that you as a customer, you act with autonomy for your own resources, right? So you can go to some cloud, you can spin something up if you want to, take it down if you want to. You don't have to call up DigitalOcean and be like, can I please have a VPS? You can do that yourself. So you manage all that through your cloud account. You can manage that, through a CLI or an API, through a web portal. There's a lot of ways of interacting, but you can view your usage, monitor your usage, deploy, take down whatever you want to do all on your own. Next is ubiquitous access. So that means that your cloud is available to anyone, anywhere, basically. There's an asterisk there, and we'll get into that in just a second. This just means that the services that the cloud provides need to be available all the time and available to people who it's appropriate to access them. We'll talk about private cloud. That's not going to be ubiquitously accessible, but for public clouds, or unless if you're like from a country that there is an SDN list or something like that. So yeah, but in the case of public clouds, your access is going to be facilitated via the internet. In private clouds, it'll be through a LAN, through a VPN, something like that. So I have an asterisk around ubiquitous access because of a couple of things. One is that assumes, like, ubiquitous is a big word. And that's a high mark to achieve, right? There's a lot of things that could interfere with ubiquitous access, right? So, I mean, we've in the US, we have a lot of limitations around Russian usage of cloud resources or cloud service providers that are based in the US. Can anyone think of any other examples where you might not have, perfect access to all of your cloud services?
Things like government usage, or I know with Azure, there's Azure that we use in the US, and then there's a separate Azure for China.
Mm-hmm. Yeah, totally. It's a great example. So Chinese cloud computing is its own thing, right? There's the Great Firewall. So all of the companies have had to create their own version of their services in China. Yeah, it's a great example. And that's a literal network barrier. Like you can't if you tried. So yeah, good example. Anyone else?
I believe AWS offers a service for FedRAMP. So
Sure.
I've worked with a company and they wanted to hire people outside of the United States, but they don't want them to actually touch the hardware. So they basically are getting a screen view of a machine through the camera because they can't actually touch the machine.
Yep. That's wild. That's wild that you got to work in that scenario. Yeah, but those things happen. And there's GovCloud, right? So GovCloud is its own thing. We're not really talking about GovCloud too much, but it's sort of cloud computing that is dedicated for US Gov, and it has different standards for compliance, for security, all those things. And that is like physically and virtually separated from the rest of cloud computing. It's similar to it touches on this idea of ubiquitous access, but I mean, one other thing is the question of just like uptime, right? So, we saw a very recent example, global example of a lot of services not having, not having perfect uptime for many days in some instances. So, the goal is ubiquitous access. We see a lot of time, and we're going to talk a lot about that in cloud native. Like, how do we manage uptime, given our expectations of uptime? We expect 100% uptime, don't we? Right? Like, if Netflix is down for like 2 seconds, everyone's like, it's a big deal. So ubiquitous access is like, it's the dream. And we like to use a lot of this kind of language in cloud computing of like, it's very idealized, and there's always an asterisk around those, right? Nothing's perfect as hard as we try. Okay, next is multi-tenancy. This one's fun. So multi-tenancy is basically just multiple customers sharing the same physical resources. So we'll talk about how that happens next week through talking about discussions of virtualization. But multi-tenancy is just the ability for customers to access, a shared resource with other people. So in that case, the customer's not deciding where their infrastructure is, or I want this virtual machine on this thing. And, it's like, it's up to the cloud, it's up to the service provider to manage that and make sure that we meet our customers' expectations of like, hey, I want, for example, like auto scaling, dynamic scaling, or I want like 8 VMs all doing the exact same thing. Like, you can set that up, but then it's up to us to meet those requirements, and you don't really have a say in how that happens. Like, to a small extent you do. Like, I want this in the Virginia region or whatever it is. Yeah, so multi-tenancy was a kind of a confusing point last semester or last year. So I just want to like pause and see if that makes sense to everyone so far. This is how a lot of like software as a service applications kind of function, and we'll talk about that when we get to the SaaS slide. If I don't talk about it, someone remind me, please. So yeah, basically we're just pulling all of our resources. You get to use them. You don't really say how, just we do it. Elasticity. This is exactly what we were talking about earlier. This is the automated ability for a cloud to scale resources as needed. And that's going to be in response to like runtime conditions. So, it's Super Bowl Sunday and your ad just blew up, and now your website's getting just a ridiculous amount of traffic. And if you've set up the correct parameters ahead of time for handling all that network traffic, then behind the scenes, it can scale in response to that runtime traffic or the runtime conditions. Or it can be done as like on a predetermined schedule, right? So you might know that there's going to be peaks in Microsoft Teams usage on Monday mornings. So you can sort of think ahead and provision additional access there. So it's not like a guessing game, I guess. Measured usage. This is just clouds, we only charge for the resources that you use for the time that you're using them. That's it. So there's really, that's why like you can spin up like an AWS account, not do anything with it for a while. You'll never be charged a thing. It's only when you start to create resources that are billable that you'll get billed. So we have to keep track of everything that you're using and for how long and how much bandwidth or how much compute or GPU now is the one that's the pricing model for that, I think, is still going to be shaking out for a couple of years. And then so measured usage doesn't just apply to billing. That's also just like the general monitoring of your resources. You need to be able to see if your resources are, like if your CPU is spiking, right? Like that should be something that you can measure yourself, not just us. And then resiliency. So resiliency, we're going to talk about a whole lot. Resiliency is a form of failover that's going to distribute redundant implementations of the same IT resources in different places. And when I say different places, I mean different physical locations. So there's resiliency baked into every data center region, within the region, across regions, and that's also something that you can help determine when you're setting up your cloud resources. So you can say, okay, I want to failover, in Berlin or in Hamburg or wherever it is. I don't recommend that if your traffic is here, but but you could do like AWS, US 1 and US West 1 and US West 2. That would be like regionally independent of each other. This could also be the overall ability of a service to just recover quickly from any disruption. So if there is a whole service that goes down, like maybe Fargate, AWS Fargate goes down or something, which would be a disaster for everyone. But like if that did go down, like what is the resiliency plan? Like how can they recover that service so that we don't experience interruptions? That goes for your own software, your own applications that you're deploying. How have you baked in resiliency so that if something happens to one of your virtual servers, your customers don't see an impact there? So it really is turtles all the way down, like the same stuff that we talk about in deploying like cloud native applications, the clouds are using them ourselves. So it's like, it's Kubernetes on Kubernetes on Kubernetes, and it just keeps going. So like these principles are really effective and they scale really well and they let us have this massive global infrastructure. So yes, we eat our own dog food is what I'm saying. Okay, so when we're talking about cloud resources, like what do we mean by those? Like we can break those down into just kind of like a handful of categories. It's compute, right? So any of your compute resources, databases, storage, networking, and then I added security because that's becoming like, even like last year, people are like, oh, well, we should tack that on to our requirements. And like this year, it's like, no, this is like front and center. This is no longer optional. This is like, I mean, I think like Microsoft employees just had that memo go out. Did anyone see this? Like all of Microsoft employees, like they're now being evaluated on the security of their code as like part of a sort of a like a first tier priority for them. Yeah, so that it's a big deal. And secure code is hard. It really is. So there's like the security of your code, the security of your containers, and the security of the cloud. We're going to talk about where those boundaries lie and in different cloud deployment models, how that changes, all these things. So we're going to be talking about security kind of throughout the class as well. But these are the basic building blocks. So, this week, next week, we're talking mostly about compute. The following week, we'll do kind of high-level database and storage. I just want you to really know about like the major cloud databases out there, and then also different kinds of databases. So most of you probably took the SQL like 531 class last year. Yeah, so you learned a lot of SQL. I've never had to use that much SQL ever again since that class, which I'm very grateful for, which is great. But we're going to talk about NoSQL databases, and we're going to talk about some different approaches and how we work with different kinds of data and how that scales in the cloud. And then we'll talk about the big cloud databases, the managed databases, if you will. The following week, we're going to talk about a lot of networking. Last semester, I think I allocated 3 classes for that. I'm assuming that everyone took one networking class in your master's program so far. If you haven't, that's okay. I will add some supplemental material so you can kind of get caught up a little bit. I'll go over the OSI model in the supplemental material so you know what we mean when we say like L7 or L2. And then we'll get more into cloud networking and so load balancing, right? That'll be a big focus. And then security again throughout the semester. And then we'll get into cloud native because you'll have these foundations to kind of work through. Okay, so how am I doing on time? Pretty good. Okay, cool. So there are these different kinds of cloud computing models. We have software as a service, platform as a service, and infrastructure as a service. Has anyone heard these terms before? Yeah, cool. Right on. So who wants to give me a definition of software as a service?
When a specific product is being hosted virtually through the cloud, but it's not like an overall platform, that would be like Microsoft Excel, specifically like Excel Online.
Yeah, exactly. Excel Online is a great example. Yeah. Yes. Anyone else? Software as a service? Yeah, the key thing there is like this is a product being offered to you, right? And you're taking advantage of it. What about platform as a service? That one's a little less common in parlance, I guess. That's okay. We'll get into it. We'll do a lot of platform as a service this semester. And what about infrastructure as a service? What does that sound like?
It sounds like you're selling like a machine or something that you could just use like, I don't know, the raw computer system or something.
Yeah, exactly. We're selling the use of our, H100 GPUs, right? That's the infrastructure that we're providing as a service. So software as a service, this is managed by a service provider. It's going to be someone, and you're usually paying a subscription model to this, not always. Basically, as a consumer, you're not worried about the underlying infrastructure. You're not worried about maintenance. You're not worried about management. You're really thinking about like how to use this service, how to benefit from this service. You are thinking about like, okay, well, how many accounts might I need for this to be effective for my business, things like that. How can I set up account management securely? How can I provide like end user training? But you're not thinking about really anything else. This is all provided for you. Okay, platform as a service is really kind of the crux of like, there's a really wide definition. It's kind of the crux of like modern cloud computing, I would say. So this is going to be an environment for engineers to create and deploy their applications. So, you know, if you have used kind of low code solutions to deploy applications, even things like Adobe, not Illustrator. Is it Illustrator? The one that lets you like kind of create web pages and like deploy them. Dreamweaver, is that it? Yeah, Dreamweaver, right, thanks. Yeah, so it's like, it can be low code. You can like choose templates, right? You can customize it. You know, on DigitalOcean, we have app platform. So you kind of bring like a bit of like what you want to deploy, and then we'll take care of your container networking. We can take care of like auto scaling, all those things. You know, every major cloud has their version of it. AWS has like EC2. There's so many things out there. But basically, the developers are not going to configure or manage servers. They're not configuring or managing databases or data centers. They're really just like setting up resources so that their application can run. And so that includes like managed databases. So what that is, and we'll talk about this a lot in 2 weeks, managed databases are basically like, here, I provisioned this entire database for you. You do not have to go spin up a machine, you know, apt-get update, you know, install Mongo. Like, you don't have to do all of that. That's already provisioned for you. And then there's even some like in some instances, there'll be like a GUI, so you can create users. You can tell it like which applications you'd like it to speak to, all of those things. And that's all kind of served up to you on a silver platter, which is great. And then it also will take care of like auto scaling. So as your database grows, then it'll scale it for you. So platform as a service is great. If you've heard of like serverless infrastructure or serverless like functions, like Lambda functions, that's a really great example of platform as a service, which sounds kind of weird, but basically you write this tiny little piece of Python code, it doesn't have to be Python, but like some function that you would like to have, that you would like to run. And rather than set it up on some machine that is mostly idle all the time, you know, maybe it's like an email blast system that you have on your website, right? And now you're paying for all the compute of just having this little piece of code here, waiting, just listening, little event listener, for some request to come in. And then it's like, great, I have something to do now. You offboard that to serverless. And then serverless is only going to run when that is called. So there's no infrastructure that you have to manage or even think about under the hood. So platform as a service is pretty cool. It's kind of a vague concept, and it applies to so many things in modern cloud computing. So yeah, we'll talk a lot more about this in the second half of the semester. And this first half is mostly infrastructure as a service. So these are the physical or virtual IT infrastructure that the cloud is going to provide to you. So that definition was spot on. Thank you. So in infrastructure as a service, you are configuring, customizing, maintaining, patching all of your own stuff. Like, we just give you kind of a blank like image, a VM, and then it's up to you to do all the stuff to it, right? So that's when you do your, you know, you do your apt-get update and your installs and your IP table configs and all of these things, right? So you're really getting into, it's like kind of the lowest layer you can go before you get to the cloud, the bit that the cloud maintains, which are the hypervisors and the underlying infrastructure. So this can also refer to storage, can refer to networking, and this just requires more engineering power overall than SaaS or platform as a service. But it also gives you the most flexibility and the most customizability. So if that is really important to you and your organization, to have like absolute full control over literally anything that happens, cool, then infrastructure as a service is available for you. It also gives you the most responsibility to maintain and secure it, right? There's not as much that the cloud is going to do to help you secure it. You're not on your own, like we secure our hypervisors and all those things. But there's a greater responsibility on the engineers. And you generally need more staff to manage that. Any questions there? Oh yeah, so I have like the big clouds here because like that's literally, that's what we're doing. That's we provide these for you. We also provide platforms. And some clouds are really getting into software as a service. You could argue like a lot of the new services that are coming out, especially around language models, are turning more into like a software as a service kind of platform, which I think is interesting. Yeah, OpenAI, like ChatGPT specifically, that is software as a service, like full blown. Okay, so now let's talk about cloud deployment models. So a deployment is just the process of setting things up and getting things running. That's all that is. You know, you're just you're shipping your code to somewhere where it can actually do the job that it needs to do. And it could be your code, it could be your resources, you know, whatever it is, just how do we get there? So there are kind of like 4 key cloud deployment models: public cloud, hybrid cloud, private cloud, and multi-cloud. So let's walk through those. Okay, so first is the public cloud. So these are like your major CSPs. These are AWS, Azure, Google Cloud, Linode, Vultr, Heroku. I don't want to leave them out either. Basically, like all parts of your application or your infrastructure are going to be deployed in this publicly accessible environment. It's owned by a third-party cloud provider. You know, if this is DigitalOcean, we own that blue bit. And you're going to access it over the internet. And when we talk about, you know, these like public cloud deployments, really we're talking about like having this separation of networks, right? So you can, okay, well, that's a little bit tricky because you can access public cloud resources via VPN if you set it up that way, but you don't have to, right? It's not a requirement for accessing public cloud resources. So yeah, this also implies a lot of multi-tenancy. So this is an example of like these 3 different tenants, we call them, or like enterprises. They're all accessing their cloud resources at the same time. It's all in the same hardware, maybe, or you know, it's all in the same data centers. They can all access it kind of equally. There's no privilege there, other than like, you know, physics, I guess. You know, if you're very, very far away, there's latency. There's greater latency in some regions than in others. So yeah, everyone's accessing the public cloud via the public internet. Then we have private cloud. So just a show of hands, has anyone heard of private cloud deployments before? Cool. Okay. So this can be a little bit confusing because it can look like a couple different things. So your private cloud can be either like it can be resources that live actually in the same building that you work in. It can be the servers that are in your IT closet. But we call it private cloud because it takes advantage of the same underlying technologies that the public cloud offers, right? So primarily virtualization, virtual machines, things like that. Generally, that's not what private cloud looks like, but it could be one definition of a private cloud. You know, my buddy Aaron, right? So generally what a private cloud is it will be like you can have it in like your data centers, maybe I used to work in New York, and we would have a data center that maintained a lot of our databases for a key application of ours. We didn't want to put it in public cloud because of latency and also just like security risks is kind of our crown jewels. So there's a data center by a private managed service provider in New Jersey, and that was close enough, so latency wasn't a concern. We had a support contract directly with that managed service provider and not with the public cloud. And then we had them maintain those servers. We had them maintain and patch and update and configure backups, all those things for us. So we would just worry about using that data in applications. So that's an example of private cloud, but it's not the only one. So in that case, like I have this like network boundary sort of defined as going up into the cloud, because that database, for example, could be like literally on your enterprise's like physical network, not even like a VPN. It's just like there on your network. Or it could also be somewhere else and you just access it over a VPN. So it's like a much more managed kind of contained world. And you are sharing resources with potentially other clients. More likely you're sharing resources with other of your own systems, right? So there might be like some dedicated hardware, in one rack. This is like New York office building rack 1 or whatever. And that's your rack. And then it's up to the managed service provider to make sure that that has redundancy set up and failover and all those things. Does that make sense? All right, cool. Okay, so then we have hybrid cloud, which is both. ¿Por qué no los dos? We've got public cloud, and in this case, like what we're doing is maybe that exact same use case. So we have our database that's across the river in New Jersey, right? And we want it there for security. We don't trust anyone with it or whatever. There's different compliance things. And then we want to use some public cloud resources, and maybe that's like a web server. And we want to take advantage of the cheaper auto scaling that's available for our web servers in the public cloud. So we're going to use both. That's what hybrid cloud means. This is, I think the majority of enterprises are using a hybrid cloud approach. I don't have the latest stats for that. I should. If I had to guess, it'd be like 60%. There is the Stack Overflow developer survey that came out, the 2024 one that came out. Yeah, did you see it? Did it have stats on this? Did you see? No?
I wasn't looking.
Oh, okay. Yeah. Yeah, it was more focused on like AI. Of course it was. Yeah. But yeah, if you're not in the habit of reading the Stack Overflow developer survey, yeah, it's great. And their infographics are always really great. And you can really get a feeling for like what the trends are for this current year, for next year. If you're like, what language should I learn next? It's like, I don't know, you can go figure out what other developers want to learn, what they wish they could learn, what they wish they could use, what they are using. Anyway, so yeah, a lot of enterprises will use hybrid cloud. If you're a smaller org, you're probably going to just use public cloud because it's going to be cheaper for you in the short term while you're scaling. Or if you don't have as many concerns around, data sovereignty. Oh, data sovereignty is a huge reason for using hybrid cloud. There's different data sovereignty laws in place around the world. So India has a pretty strict one. So any data about Indian civilians has to stay in India. Any computation about Indian civilians and their data needs to stay within India. So there's a lot of database stuff and computation happening within that perimeter. And then other resources used, maybe like CDNs, content delivery networks, like around the world. The EU has keeping on top of everything is a challenge, but lots of hybrid cloud deployments out there is the point. Multi-cloud, this is just, hey, we use a bit of AWS, a bit of GCP, and a bit of Azure. It just lets you like kind of pick and choose. Multi-cloud deployments are really popular, especially in the case of like, well, our productivity software for our organization is all through Google Cloud, but our application systems are all in the AWS. That's a very common use case. Or maybe you're using Databricks. So all of your stuff's in Azure, like Azure Databricks, but then your application servers in AWS and your productivity software is in Google Cloud. So multi-cloud, I think we're all pretty familiar with it. Yeah.
Are all multi-cloud, like, would they all be public clouds then, or is it would they have?
Good question. When we talk about multi-cloud, we usually mean public clouds. Yeah, but you can be multi-cloud and also hybrid cloud. Yeah, you can, it's choose your own adventure with the amount of complexity you want to manage. Yeah, sky's the limit. So, yeah. Okay, so let's move on to, because I think we only have 10 minutes. Okay, so there's a out of all this, like we've talked a little bit about the advantages of cloud computing, especially like, elasticity and hyper and auto scaling, not having to manage your own physical resources. But there are some clear like definitions, and a lot of these come from AWS. If you want to take like the AWS exam. Oh, sorry, let me pause for 1 second. DigitalOcean is funding our class, but I'm not teaching a DigitalOcean class. I just want to be clear about that. Like we're going to teach all the clouds. Like and I made that clear to them. Like I don't want you to feel like this is you're being shoehorned into, yeah, this wasn't a bait and switch, I promise. Yeah, so we'll use other clouds especially like for learning like VPCs. We'll and like networking. I think like AWS is like a really great primer for networking. Just the visual nature of it is cool. For learning like the different kinds of like image sizes that you can use. We'll use Azure for that. I'm not teaching a DigitalOcean class, just to be clear. So, but I bring that up because 6 advantages from cloud computing, this does come from the AWS world. And this would definitely be on, a certification exam if you're like trying to take an AWS, cloud associate exam, I think is the entry level one. This kind of stuff will be on there, just so a heads up. So 6 advantages of cloud computing. The first is we're going to trade capital expense for variable expense. All right, business school people, what's a capital expense? What's CapEx?
Any expense used for expansion.
Yeah. So it's gonna be like your big ticket spending. Yeah. You got to budget for it well in advance, sometimes 2 years in advance, 3 years in advance. And then, the rest of your budget kind of fits around your capital expense. In this case, we're going to trade with cloud computing, we're going to trade our capital expense for variable expense, in this case, operational expenses. So you don't have to save all the money to buy an H100 GPU. You can rent it. So this turns into, a variable expense that you can then have a little bit more granular control over. You don't have to sort of like pre-budget for it. I mean, maybe for use of H100s. If you're doing a lot of training on H100s, you've already budgeted for that. But but if you need a quick little web server, then that didn't need to be accounted for earlier in your budget. So that's a big one. And this gets a little bit tricky because have we gone too far into capital expenditure on the cloud side is a question people are asking. So we worry about the capital expense, and what we do is we scale that like crazy so that you can benefit from economies of scale, right? So we stockpile the H100s, and which maybe that drives up the price, who knows? But we have a fleet of H100s, every cloud will, and then you get to then rent the use of that, and then the costs come down for you. They're going to kind of keep coming down, arguably. Let's not talk about GPUs; it's too complicated right now. But let's go back to back in the old days where it's just beefy CPUs. You can rent the use of these CPUs for very, very cheap because we have so many of them. And so because we have all of these set up, you can have that deployed $4 a month, for example, to run a little web server. Sounds pretty good. Stop guessing capacity. So one of the key reasons that economic drivers of adopting cloud technology is because what you'll end up doing if you ever worked in the shop by a shop, that's old school. If you've ever worked in an organization that has a lot of on-prem infrastructure, then you'll know your server room, sometimes it's just kind of idle. There's a lot of compute that's just there, just spending money. It's just depreciating before your very eyes. And you're powering all this, and then you're cooling it, and that capacity isn't really being used. The thing is, if you under-provision capacity, that's even worse, right? So if you under-provision and then all of a sudden your website gets a huge amount of traffic and you can't support it, and it crashes, that might be good marketing actually, but but in most cases, that's not a good thing. So you kind of have to be able to guess what your maximum capacity and your minimum capacity is before you even set up your closet or your server room. You run out of racks sometimes, right? And racks are expensive, even just the racks themselves. Oh my gosh, don't get me started. And then all the cooling, and if you didn't set it up perfectly with your hot aisles and your cool aisles, it's a disaster. So if you're trying to do all of that in-house, you are doing a lot of guessing. And with cloud computing, you don't have to do that guessing anymore. You're here's, you find that you're out of capacity for the virtual machine that you spun up, you can expand that capacity without having to do anything. You can just click a button and it will auto resize it. It can't go smaller with disk size. It can with compute, but not with disk size and there's some other caveats there. But you don't even have to mess with that machine itself. You can set up auto scaling. So then as capacity is reached on this machine, pop, pop, 3 others will pop up, and it's cute. And they're they're like daisies. So you don't have to guess your capacity anymore. You just are going to pay for what you actually need. Increasing speed and agility. It's faster to go to market. It's so much faster. You don't have to provision hardware. Man, anyone ever do procurement? In gov work, oh my gosh, it's okay, well, 10 years from now, we'll have that application deployed, that the 4-star requested 6 months ago. Yeah, so just your go-to-market time is it's dramatically reduced. You're going to stop spending money running data centers. That's real nice. And you can go global in minutes because we have clouds offer CDNs. We also offer redundancy in different places. So CDN is a content delivery network. You can just have additional copies of whatever it is you're distributing all over the world. So in the old days, I don't even remember these days actually. I'm talking I remember before CDNs, but yeah, but before cloud, for the wide adoption of CDNs, you actually had to go to a location. You had to go to the UK and spin up your stuff in the UK and provision your hardware in the UK, and then you could serve the EU, right? So that sucks. But now you can just kind of you can, it's with a couple of configuration files, a couple of YAML files, and you can kind of go global. Okay, so I know we're almost out of time. Major cloud players, this is from the 2023 Stack Overflow survey. The new one just came out, so I didn't get to take a look at it yet or put screenshots in it yet, but if only they had known that my class is starting today, they could have put it out like 2 weeks before. Anyway, Stack Overflow developer surveys, like we can see these are, at least for last year, the most major players. If you're not familiar with all these names, that's okay. Some of them are like OVH is predominantly in Europe. OpenStack, IBM's, they had high hopes. Anyway, but I am not talking badly about a competitor. I think they do some really cool stuff. I wish they were more popular, actually. Yeah, but you can sort of like see who the major players are. And then cloud is really driving technology adoption everywhere. So this is in the Stack Overflow developer survey. This is orthogonal to how they might be using cloud. But that said, cloud is driving everything. So Docker is the most used technology like ever. I think the same is probably true this year. NPM, package management for Linux. We'll talk about why Linux is everywhere in cloud next time. Kubernetes is up there, like 25% of developers are using Kubernetes. Like that's so much. Terraform, that's infrastructure as code. Ansible is the same thing. These are all for managing like mass deployments and having really specific configurations for all of your deployments. So Chef 2, Puppet, Unity is kind of orthogonal to cloud. Yeah, cloud is just, it's not just within the cloud world, but it's also outside cloud. If you're a developer or a product manager or data person in this world, cloud is driving what you're using. So this was the macroeconomic landscape from 2023. This is what we were dealing with in terms of like thinking about like how we're using cloud resources. In February of 23, right, there was huge tech layoffs and that kind of persisted throughout the rest of the year. There was a tech market downturn. Stocks were looking bad. Saving costs was the key focus last year, right? Every CEO was and a CFO and CTO were hyper focused on saving costs because all of a sudden in the tech market, investors expected free cash flow for the first time in like 15 years. And so that was really important. So everyone was scaling down their operations as much as they could. So if you could save money, you were doing it. For a lot of people, that meant going to the cloud. So that was last year. This year, obviously, like AI is one of the key macroeconomic landscape drivers. Massive VC investment in AI, specifically generative language models. And I have some business case studies, both like they're very, very optimistic about that and also less optimistic about that. I'll have that in your reading in a couple of weeks. But just overall, there's a lot of uncertainty. Like no one knows, right? Like no one knows if this AI investment is going to pay off. Like what do we all buy these H100s for? Like, are people going to actually use them? I hope so. That would be great. You don't have to just use them for language models, right? You can use them for a lot of other things. But just there's uncertainty in the market. No one's really sure what's going to happen. People will tell you that they're sure, but no one knows the future. And there's a huge driving security investment ecosystem going on right now. So people are really, really upping security investments, and usually security and AI put together. Some people are good at that. Most people are not good at that. But this is where a lot of this is going. So now a lot of cloud providers are making the case of like, hey, AI and security, that's why you come to the cloud these days, right? So you're going to see a lot more of this and how you can future-proof yourself from weirdness in both AI and security. Yeah, so developer survey, if you want to link to that, that's in the references. Land acknowledgement statement, just because I think that's important. And that's our class for today, and only 1 minute over. Yay. Thank you, everyone. I'll see you on Thursday. Yay, thanks. Thank you.